Okie donkey, okie donkey. So hopefully you found that this was divergent. Let me show you a picture of this function and also 1 over root x together, and we'll try to make sense of what we found here. Okay, so here they are. So pause and copy this. Now, what did we find? Well, look how, well, I can't, it's kind of vague here, but look how far away this is from the y-axis here. Okay, it's quite a bit further away than this green bit here, right? That's very roughly what we're talking about here. Okay, I guess you could say the blue curve fails to approach the y-axis fast enough. And the green curve, it approaches the y-axis quite quickly. Relatively quickly. You can also see what's happening from 1 to infinity. Well, in the sense that the blue curve is approaching the x-axis quite a bit faster than the green curve. This goes some way towards making sense of the integrals we found. Anywho, let's go back to where we were. Okay, I want to do an example. I think the kind of missing example here, 1 over x, what happens there? It's kind of a special case. I do it just because ln is not something that students are super familiar with, but you need to be. So I'm going to ask you to memorize this graph of ln of x. Okay, so 1 over x becomes ln of x. And then you have to think about ln of 0. You got to think about that. Okay, how do you think about that? Well, you got to memorize the graph. Okay. And from the graph, you can think of this as minus infinity. That's really awful. Let me make that a little bit prettier. There we go. There we go. Okay. Okay. Oh boy. Oh dear. Oh boy. Oh dear. Oh dear. Oh dear. Okay. Pause and copy all this lovely notation. Nothing super new here. It's just put down in a rather formal way. Okay, for ABC, I give you pictures to try to illustrate what this might look like. Okay, again, for part C, if we break, doesn't matter where you break, we call this letter H the breakpoint. And again, we insist that the two pieces converge. Now, you'll see and possibly be annoyed by the fact that I'm using a letter T here. It doesn't really matter. When you introduce your limit, I choose the letter T. You can choose the letter L or P or Q. Doesn't really matter too much. Maybe you want to break into Greek letters, use a phi, whatever, who cares? Pi is reserved, and oft E is reserved. But the letter here, T is, I don't know, doesn't really matter that much what letter I use. Hope that's not too confusing. This is a bit dense here, so please ask me if anything is not clear. Okay. Pause and copy what I have here for the example. I'm going to grind through some examples here just to give you some experience with this stuff. Now, I need to locate my discontinuity first. Okay, I need to locate these any asymptote that may be occurring between 0 and pi over 4. So I take tan and I write like this. And I say, what's the possible problem here? Well, the possible problem is division by 0. So when is cos 2x 0? Well, it's at x is equal to pi over 4. Okay, so this is my problem. The 0 is no problem at all. Okay, plug 0 in here, no issue. So pi over 4 is my problem. So this is the guy that will become t. Okay, and I've reasoned this out in the green rectangle here. So t is going to go to pi over 4, and it's going to approach from the left. Oops. Okay, this little diagram down here is useful to see why I have a minus here. Okay, situate my t between 0 and pi over 4, and it's moving towards pi over 4. So I can see that it's approaching pi over 4 from the left, so giving me the minus there. Okay, introduce my limit. For the antiderivative, I'm not going to show you. I did u is equal to cos 2x. So if you are concerned about that, I would recommend you take it aside and try it on your own. Now I'm going to plug my t and my 0 in, and I'm going to try to work it out, and I'm going to not have much luck here. It's going to be divergent. Again, we have this ln of 0, which is, as we saw before, ln of 0. You can think of it as minus infinity. Okay, thought cloud. Don't write that unless you put a thought cloud around it. So I'm not getting a number here. Okay, my final limit here is not resulting in a number. So we have a divergent improper integral. Okay, I want you to try this improper integral. And you should start with u is equal to cosine of x. So if u is equal to cosine of x, what is your problem with this fraction? Okay, division by 0 is almost always the problem that we're looking at here. So when is cosine equal to 0? Well, it's the pi over 2. That is a problem again. So I'll write that t is going to pi over 2 and minus. Okay, one thing you may want to remember, which I think is always true. Okay, if this is the thing, if it's a little bit vague what I'm about to say, if you're replacing this with t, the guy on top, then you're going to have a minus. If you're replacing the guy on the bottom with t, then you're going to have a plus. Maybe you want to rewind the video and hear that again. Okay, x ln x. Okay, here's a case where we don't have a denominator. But there is an asymptote. Okay, ln of 0 does not exist. Okay, it's the minus infinity I talked about up here. Okay, so that's my problem spot. So I'm going to put my t for my 0. Okay, which is saying this blue or green circle here. Okay, pause and copy all this. I do the by parts integration for you here. Very nice that way. And I plug it in, blah, 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 blah. Not too much interesting here. Let me see. Oh, there is some interest here. Oh, there is interest. Let me just pause and copy here. So I do my by parts. I throw it in here. And then I say, hold your horses. T squared ln t. That is of the form 0 dot minus infinity So that is a indeterminate form, so I need further investigation, almost always using L'Hopital's rule. So I do L'Hopital's rule here to figure it out. And in this case, I'm pulling t down to the denominator. This moving ln down is not generally going to help you. And now I'm ready to evaluate all four pieces up here. Okay, limit of 0 is 0, which I don't even bother to write here. And then in blue, I found this 0 here. And then t is going to 0, so this last bit ends up being 0. Okay, it's worked out to -1/4, which is a real number, so convergent.